need to compute the y over the x. So the thing of y is this one, composition of the following. You send x first to what is inside, and then you send that, let go what is inside is u, and then you send that to square root u, which is square root of this, which is called y. So now dy over dx by chain rule is dy over du times du over dx. Dy over du is square root of u prime, which is 1/2 1/2 square root of u. Du over dx is d over dx of this term. And now this is 1/2 square root of u d over dx of this. So this one is this one prime plus this one prime with respect to x. So d over dx of this term plus d over dx of the second terms. D over dx 2x4 d over dx secant 4x. And so the first one here will keep the same. This term is 8 times x3. The next one, if you want to change rule, then let's write down this separately. So the only thing left to compute is here. So you can think of that as you have x sent to 4x or t, and then you send that to secant of t, which goes v. So d secant of 4x, secant of t is secant 4x, dv over dx, or d over dx of secant 4x is actually dv over dt times dt over dx. So dv over dt is secant t d secant t over dt, d over dt of secant of t, dt over dx, which is 4x prime 4. So d secant prime secant tangent secant prime secant tangent. So secant t tangent t times 4. So t is 4x. This one gives us secant 4x tangent 4x times 4. That this term. So now put everything together. What we have is 4 times secant 4x tangent 4x. That is the answer. Now if you want to reduce this 2, then you have 1 over root 2x4 secant 4x times 4x cubed 2 secant 4x tangent 4x. That is the final answer. We want to compute dy over dx, where y equal to this. So if we want to draw the chain in chain rule, so here's how we do it. We start from x. We need 2x4. We go to x4 first. Let's call this one u. U equal to x4, and then you go to 2x4, which is 2u. 2x4, and we call this v. That gives us the first term. Now we want secant 4x, so we go to still x here. We go to 4x, which I call is omega. Then we go to secant omega, which is secant 4x. Let me call this t. So we have the second terms. Now we have the blue plus the pink, v plus t, v plus t, which is 2x4 secant 4x. Let us call this z. And now we need to square root of z. Square root of z. On z power on half, which is y. So at the end of the chain here, this is y. Now let's apply chain rule. We go this direction to here. So dy over dx is dy over dz. So we are here, dy over dz. And then to be here, you need to go this direction and this direction. Therefore, this would be the first direction. Let's say the blue one. We need to do dz over dv times dv over du times du over dx. dz over dv, dv over du, du over dx. Well, so the first branch, the other branch, you go from here to z. So what we do is dz over dt times dt over dw times dw over dx. dz over dt, dt over dw, dw over dx. Yeah. Now we compute each one of them. dy over dz. Y is square root of z, or z power on half. That's the first one. Now inside you have dz over dv. dv, so z is v plus t. This is this one. dv over du, d over du, so v 2 times u. I copy this whole thing. du over dx u over dx, u equal to x4, so d of dx4 over dx, so like x4 prime dz over dt, which is a derivative of z v plus t dt over dw, or dt over the omega secant omega and the omega over the x, so 4x. Now we are almost done. dz over dz power 1/2 over dz 1/2 z 1/2 minus 1, so minus 1/2 inside dv plus t over dv is 1. These terms give us 1. The next terms give us 2. So times 2. The next one give us 4x3. The next one give us 1. The next one secant prime, so secant tangent, secant tangent, secant prime, secant times tangent, secant omega tangent omega. And the last one dx d4x over dx, so which is 4. Now just put everything in terms of x. 1/2 square root of z, square root of z, these terms inside 2 times 4 8x3 4 secant omega which is secant 4x, omega is 4x, secant 4x tangent omega tangent 4x. So eventually we get this term divided by 2 times this. You can cancel 2 out. 4x3 2 secant 4x tangent 4x square root 2x4 secant 4x. So it's very lengthy, and this gives us this. Now, when you're comfortable with chain rule, just apply this and write directly. Use this formula. F of g of x prime, this is f prime of g of x times g prime of x. So we think of this as, this is g of x, and f is just function, the square root function. Dy over dx will be that the one inside is 2x4 secant 4x power 1/2. So now we have prime, that's 1/2 2x4 secant 4x, right, 1/2 minus 1 minus 1/2, that is f prime of gx, f prime, now times g prime, which is this one prime, g prime, g prime x. So in this case, this one prime. Now we continue. The first term is done. 1/2 square root 2x4 secant 4x. The other term 2 4x3 secant 4x prime. Now you change rule again for this function. Which is, so secant tangent, so secant times tangent. Secant 4x, tangent 4x, and then you still need this one, gx prime, g prime x 4. So that is why you have the same answer as before, but much faster. Now you can cancel out the 2. 4 here is actually 2 times 2. And to distribute that, you can pull the 2 out. So to write nicely, you can pull the 2 out. Inside you have this. So which cancel the 2 down there. What you have at the end is 4x3 2 secant 4x tangent 4x square root of this. So let's compare with the first one. We get the lengthy ways of writing with this one. 4x3 2 secant 4x tangent 4x over square root of this. Yeah. So from next time, just remember this formula, and this will be enough.